Yes, go ahead, Peter.
Okay.
Welcome to the OSACon.
Okay, thank you. So my name is Peter Zaitsev, and I am CEO of Percona, and I'm going to talk to you about managing transactional and analytical workloads with open source databases. Now, a word of caution, that will be highly opinionated session, because myself, I came from mostly open source transactional or operational databases background, though of course because of involvement in this industry, I also have seen a lot of things going on with analytical databases as well. Also, my experience is peculiar in what I have started with databases in early 2000s, when you can see their modern web was being really rebuilt on the ashes caused by .com crash. And for us, the open source geeks, while we knew what there are various expensive enterprise-focused analytical solutions existed, there was not really a lot of analytical focused solutions for open source as an open source at that point in time. Really, right? So really what we had been doing with open source is often some sort of coping. Of course, the ETL process existed, and we would use MySQL or Postgres, other databases to build the summary tables. We'll try to denormalize the data so we can avoid joins and have it processed a little bit faster. There have been also many scripts built to have a distribute query execution, do it in parallel or distribute it among multiple shards, as well as many people have had built many custom purpose-built reporting solutions. And what I mean is you can see many folks of the era saying, well, you know, if it's not really fast enough, maybe we're going to implement some sort of daemon in C++, which will, you know, speed out us reports what we are requiring very quickly. Then later on, we see Hadoop enter the space. And at that point, that was really fantastic reporting frameworks, which really was focused on massively parallel executions. So if you have a ton of data, you can just spin out thousands of servers and massively crunch your data in parallel on them. It wasn't quite focused on real time. It also was not even SQL to begin with, if some SQL solutions appeared later, but that was a framework. And I think what started to happen at that point is their MySQL or Postgres, which are great open source database, but not particularly focused on analytics, starting to be used less of those workloads, and open source analytics was moving to somewhere else. In this case, we also started to see that there are actually many different kinds of analytics, right? We look about the business intelligence folks, data science folks, right? You see the terms as big data in use. At the same time, there are solutions for analytics needed as in product reporting, right? Which basically means, hey, I am a user and I just want to get some basic information about how my site was visited, right? Or how my book was sold, or stuff like that. With this kind of analytics, we can see that there is a lot of different criteria and needs which have emerged, right? In certain cases, you're thinking about data, which can be structured or unstructured. Data volume can be very different. The data velocity, that is, becomes another important component. Hey, how much data do you ingest in the system, and maybe purge the all data, right? And so on and so forth. And why I'm listing all that stuff here is because of so many different and often conflicting criteria. That meant what it's not just going to be one solution to serve all those needs. Because typically when you build something, you have to make certain trade-offs, right? Here, I think another interesting thing what happened, we have the cloud really seriously enter into the picture. And I think when it look at the analytics, cloud was particularly wonderful because cloud provides us availability of infrastructure at scale with programmable API, and we could also do some temporary provisioning. So in the past, if you are talking about your own data centers, if I need to spin out the 1,000 servers to run some Hadoop jobs, well, that probably would require a lot of lead time and CapEx. But if you're speaking about the cloud, spinning up 1,000 servers for a day or two is not particularly expensive. In the cloud, though, we had a lot of proprietary solutions being bought and built. Some of that, I think, is because in the cloud, there is no zero price effect, which was really important driver for open source. What I mean by that is what in the cloud, you anyway pay for cloud resources, compute, storage, and so on and so forth, right? So you cannot just say, hey, I have open source software, and now it's kind of free for us instead of paying a lot of licenses, right? Also, the managing large-scale distributed data infrastructure, which analytics often requires, is hard, especially for data scientists and other kind of data consumers, which are not very technical people in many cases. And also cloud vendors could afford to have increased efficiency and with that even lower cost sometimes, because they can do custom hardware, they can allow multi-tenancy, which you cannot really do as easy in your public or private data centers. With that, we see a lot of vendors in this case being born, both with hyperscaler clouds, right, as well as other large vendors, such as in particular Snowflake, Databricks have analytical solutions for many clouds. Another interesting trend, what I see is what for a lot of what you can say like a light duty, medium scale analytics, we see what the vendors have been implementing the cloud only extensions for some open source operational databases, such as Amazon Aurora has parallel query, Oracle makes Heatwave available, which is only available in the Oracle cloud, right, which is not available if you just run open source edition. I think what you'll find, which is very interesting, is what the analytics in a cloud is typically provided as a database as a service. And I think that is not really surprising, because database as a service that offers us state-of-art simplicity. It really allows a very kind of high level of automation working with that. And it really maximizes developers' focus on the application over other needs like reporting rather than managing databases. But that also in a database as a service comes with a serious problem, which is called software vendor lock-in, which sucks. And if you think about the history, which I think a lot of enterprises learn, and some of them remember, is what that happened before, right? This person here is young Larry Ellison, and some people may remember what in the past Oracle was saving people from the hardware vendor lock-in dominance, which was coming with Big Blue, IBM. Well, guess what? How situation changed, and I think now in a database circle, Oracle is quintessential example of that very expensive lock-in. Now, I believe we'll see the open source coming to the rescue as it happened before. Now, if you remember in 2000s, we used to have a lot of development stack, such as ASP.NET, which especially in the enterprise space were much more respected and productive than open source alternatives. Guess what? Open source caught up. I believe right now we have a similar situation when there are a lot of proprietary solutions exist in the cloud. You can also make some other examples here, like operating system. I remember with my career with Linux started in late 90s, and Linux was really seen as a joke by Solaris, AIX people, and so on, when they were saying, well, what the hell is this operating system? It can't even handle files more than 2 GB in size. But well, there is Solaris now. And I believe what we will see open source catching up again when it looks about the databases and analytics in particular. And I think that is where the Cloud Native Computing Foundation is doing a lot of great work promoting the alternative stack or set of solutions which exist compared to the proprietary Lockin with some given cloud vendor. And I think what that leaves to the cloud is really its originally intended and advertised role as something of a commodity infrastructure simple to the utility service. Now, with that kind of historical and visual part, let's look a little bit at the modern patterns which we see in terms of data analytics. You can, if you need both operational and analytical data in your application, there are pretty much two approaches. You can either have HTAP, where you have the same system which handles both analytical and transactional workloads, or multi-store, where you have a different systems. In terms of an HTAP, I think it's mainly used for kind of like a smaller scale light duty analytics, which we can see either as parallel query and sharding support and transactional engines, which makes some medium complexity analytics possible, or solutions like PinCap TidyB, which essentially do the multi-store concept internally by storing the data in two different forms. If you look at other approach is using Apache Kafka, which really has become as a leading open source data pipeline. There are a lot of people would use Kafka as a data bus, which used to move the data between the different purpose-built systems, where you may store data, I don't know, in MySQL as your main operational database, and ClickHouse for analytics, and then Elasticsearch for full text search, or maybe OpenSearch those days if you want to stick to the open source ecosystem. I think another big innovation happening right now, which is important, is the Kubernetes, which is an API which became universally available on a private and public cloud. And I think that is a great, it's getting better and better for managing stateful applications. With that, you can see what the Kubernetes operators are available for many open source databases, analytical and not. Why Kubernetes operators are important? Well, because they really can help a lot with the day one and day two automation to reduce waste and toil similar to a database as a service. Though the UX is kind of different, right? When you speak about many databases as a service, you can provision that data in 2 clicks, not the same with Kubernetes. But I think that Kubernetes gives us a great power how to build open source database experience, which can be providing the main options, where you can think about deploying it as a managed solution in the cloud with a single tenant and multi-tenant architectures, which both have their benefits and drawbacks depending on the use case. And then also something where you can deploy it in your own physical or virtual data center, right? To have a what is a modern term, data sovereignty, to discard that. With that, I think that is where we are going. I am would say what we are not there yet as an open source database community, but we are taking baby steps, and well, maybe even not so baby. If you ask me if that is something which can be done, I am quite confident what that is possible, and I really expect in the next few years we'll see a lot of traction from open source analytics and taking a bigger pie in the overall analytics space. That's all I have for you folks. And yeah, Alex.
Thank you,
take it
Peter.
back.
Thank you, Peter. Any questions? That was a great talk, a very good overview of history nowadays and the future. We'll see how it goes in the next couple of months.
Yes, we'll see. Maybe you say, okay, Peter, that was such a bullshit. We'll have Oracle taking back the universe. Yeah.
Maybe, but.
Oh, maybe you'll tell me, hey, Peter, you were right.
Okay, thank you, everybody. And let's go to the next talk.